In question 6, we have a circuit diagram allowing us to find the terminal potential difference across and the current through a cell with an internal resistance, as the circuit resistance is reduced using a variable resistor. We have a graph of the terminal potential difference against current. In A, we need to explain why the terminal potential difference decreases as the current increases. Well, as the current increases, a greater potential difference across the internal resistance is required. In B part 1, we need to use the graph to find the EMF of the cell. Well, the EMF is the terminal potential difference at zero current. This is the y-intercept, which occurs at 1.52 volts. In part 2, we need to use the graph to find the internal resistance of the cell. Well, the internal resistance is given by minus the gradient of the graph. The figures I've taken are taking the voltage to 1.52 volts from 0.2 volts and to 0 amps from 3 amps. This gives an internal resistance of 0.44 ohms. In C, we have a sketch of the graph shown here. We need to draw a line on the graph to show that the results. For C, I've done a simple copy of the graph. In part 1, we need to add a line to the graph showing the results obtained from a cell with the same EMF, but double the internal resistance. Well, this will have twice the gradient. We need to label this A. For part 2, we need to add a line showing a cell with the same EMF but negligible internal resistance. Well, this will be a horizontal line, and we label this B. In D, we're told in the original circuit the variable resistor is set at a value such that the current through the cell is 0.89 amps. In part 1, we need to find the charge flowing through the cell in 15 seconds. Well, charge is current times time. Putting in the values gives a charge of 13 coulombs. In part 2, we need to find the energy dissipated in the internal resistance of the cell per second. Well, this is the power, which is given by current squared times resistance. Putting in the values gives a power of 0.35 watts.